Number 19, while playing a golf video game, Anna hits a ball 35 degrees above the horizontal at a speed of 40 miles per hour with the 5 miles per hour wind blowing, as shown. Find the resulting speed and direction of the ball. So the wind is blowing straight east. So here's the ball. And that's 40 miles per hour. This is 35 degrees, and then the wind is pushing it to the east at 5 miles per hour. So the flight of the ball should be something like that. So let's go with ball is 40, and then cosine of 35 degrees and 40 sine of 35 degrees. The wind is 5 cosine of 0 degrees and 5 sine of 0 degrees. The resulting path, when you add these two together, I did the calculator work ahead of time. This ends up to be 37.766 roughly. I plugged that into A. I stored that into A. 22.943, and I stored that into B. So the magnitude of R ends up being the square root of A squared plus B squared. And I got 44.188. And then you can see they're saying that the answer is 45. Then we want the angle. So inverse tangent of B over A, I got to be 31.278. Make sure your calculator is in degrees. And they just said that the answer is 31 degrees. Number 20, a charter boat leaves port on a heading of north 60 degrees west for 12 nautical miles. The captain changes course to a bearing of north 25 degrees east for the next 15 nautical miles. Determine the ship's distance and direction from port to its current location. So if we start the boat down here, 12 nautical miles, 60 degrees west. So 60 degrees west, and we'll call that 12. So that's 12. This is the 60. So if I add 90 to that, that's going to be 150. So the first part of the leg of the trip is 12 cosine of 150 and 12 sine of 150. Then we'll get the second part of the leg. And let's see, that's 25 degrees on the east side. 25 degrees on the east side of north. And that's right there, 25 degrees. So this is 25 degrees, but we need the unit circle measurement, which is going to be 65 degrees. Now that's 15, right? Yeah, that's 15. So 15 cosine of 65 and 15 sine of 65. And the result, the path, or the distance and angle from where it started is, see, I did that also ahead of time. This ends up being negative 4.053. Of course, I put that into A, stored the whole value in A. This ended up being 19.594. I put that in B. So the magnitude of R is the square root of A squared plus B squared. And what we're trying to find is, let me use a mouse for this, that vector right there, the resulting vector. So I got the magnitude on this one to be not 19.5. I tried this several times. This is what I could get every time. So I don't know if I'm making a mistake. If I am making a mistake, I'll come back and I'll let you know. But I could not get the 19.5. All I could get is 20.0093 without rounding A and B. And then we have the inverse tangent of B over A. And that, I got 78.3135. I actually got negative that, which is telling me that the answer's in the fourth quadrant, but it's not. So we have to add 180 to that. And I got 101.686. That means this is 101.686. 686, but I'm going to knock off 90 degrees from that because we're going to give it as, north 25 degrees east or whatever we need to. So I'm going to minus 90 degrees from that. And I got, that ends up being roughly 11 degrees, but that'll be on the west side of north. So north 11 degrees west. And we can see that answer right there. A runner's resultant velocity is 8 miles per hour, due west, running with a wind of 3 miles per hour, north 28 degrees west. What is a runner's speed to the nearest mile per hour without the effect of the wind? So let's start the runner. Right there. Like this. The runner is headed straight west. This way. Now, if the wind is pushing... Let's see, how should I do this? The wind's direction is actually this way. But we'll go end to end here. And it's actually pushing the runner like that. So the runner is running in this direction, but the wind is pushing so that the runner ends up running straight west. Let's get some measurements here. This is 8, and this degree right there, that's the 28 degrees. So if this is 28 degrees, then this would be 28 degrees, and then inside the triangle would be 62 degrees, because that would have to end up, that would have to be 90. Well, the wind is 3 miles per hour, and we want this side over here. We want where, how the runner is running without being pushed. Well, that's the law of cosine. So we have r squared is equal to 3 squared plus 8 squared minus 2 times 3 times 8. Law of cosine. So cosine of 62 degrees. R squared is equal to, where do I have it written down? 50.465, and a little bit more. And then when we take the square root of that, it ends up being 7.10389. So they're saying 7 miles per hour. That one's a little different in that they give you the resulting speed. A glider is traveling at an airspeed of 15 miles per hour due west. Due west. Let me see. All right. So let's start over here. So going due west. Glider's traveling at a speed of 15 miles. That's 15. If the wind is blowing at 5 miles per hour in the direction of north 60 degrees east. So on 60 degrees on the east side of north. So that is 60 and at 5 miles per hour. So this is going to be the resulting path right here. So the glider's path, not the resulting path, but the direction it's headed, trying to head anyway, is 15 cosine of 180 and 15 sine of 180. The wind is, let's see, 5 cosine, but now we don't want the quadrant angle. We want the unit circle angle. That's 30 degrees. And then 5 sine of 30. So the resulting path is going to be, where do I have this written down? I see it now. Negative 10.669 and 2.5. So the magnitude of r is equal to the square root. I stored that in a, stored that in b, even though I didn't really need to store it. A squared plus b squared, and that ended up being 10.9588. So the answer book is calling it 11 miles per hour. I did one more. Kayla is swimming due west at a rate of 1.5 meters per second. A strong current is flowing south 20 degrees east at a rate of 1 meter per second. Find Kayla's resulting speed and direction. So Kayla's swimming west. All right, swimming west. This direction, that way, at a rate of 1.5. So we'll put 1.5 here. A strong current is flowing 20 degrees east of south. 20 degrees on the east side of south. So this right here, this is the 20. And the magnitude is 1 meter per second. Find Kayla's resulting speed and direction. So like this right there. And so let's talk about Kayla. That's 1.5 cosine of 180 and 1.5 sine of 180. The current, let's say C for current, is 1 times cosine of, well, we need the unit circle measurement, so all the way around. That'd be 270 plus another 20 is 290. And then 1 times the sine of 290. So the resulting path is negative 1.15797. I put that into A. And negative 0.9396926. I put that into B. So the magnitude of the resulting path is the square root of A squared plus B squared. And I ended up with 1.49 in meters per second. That's what the answer book suggests. Then we have inverse tangent of B over A. I got 39.059. But that's like this. That's up here. So this right here, this is the 39 degrees. But we're given as, south 20 degrees east. So I need this right there. I need that measurement. Well, if that's 39, this is 39. And then this is going to be 51. So 51 degrees, and that's going to be on the west side of south. And that's what they get for an answer up there.